Hello, this is going to be Exercise 1 demonstration in GIS 101 Fall Semester 2012. In Exercise 1, we're going to take a look at how we want to process some vector and raster data for an area in Yosemite National Park. And this will give you a good chance to practice with a lot of the basics, uh, fundamentals of downloading data, defining projections, reprojecting the data, and so forth. Just basically the main things you need to do to get data downloaded, processed, and included into a project. So this should give you some very good hands-on experience with working with this type of data. So to begin, the first thing we want to do is make sure we have our folder structure defined properly. This is really critical because you're going to over time be accumulating a lot of data, and you need to have a good organizational scheme set up in advance so that your information is properly located and accessible. So to do this, let's open up our Windows Explorer, and in Windows Explorer on your C drive, and you'll notice in the instructions, and you'll hear me mention this a lot, to make sure your quote working folder is located on the root of your C drive. And by that I mean just simply clicking on the C drive, and then here you see the folders that's directly on your C drive, and go ahead and make a new folder there. We'll right click, say new folder, and we'll call this new folder GIS 101, and just make sure that this folder is on your C drive. As you can see up here at the top, not embedded in your My Documents or embedded on a zip drive or anything like that. We're putting this on the C drive. Now let's go inside that folder, and let's make another folder here, and we'll call this one EXER1 for exercise 1. Now at this location here, you'll have some over time you'll have other folders that you'll set up for other assignments and so forth, and so consider this your working folder, and we are now going to go inside the working folder for exercise 1. So we'll double click on that, and in here let's make several subfolders, and let's start with a DOQ, and you'll notice these are names of different types of data, and basically it gives us a location to put that data. As we download it, we'll have a place to file it away so that we don't have to worry about moving it around later and so forth. If you have to move folders around later, that can break links that are set up in your project files, your MXD files, and that can cause you some problems later. You can resolve those problems, but it takes some time. So we're going to set this up with a structure that should work for us for the rest of the semester. And then we'll have base data. And by rest of the semester, I mean, with the 101 working folder. This one here is specific to exercise 1. So here we have several subfolders set up, and this gives us some location to store data as we download it. Okay, the first site we're going to go to download data is we're going to obtain some raster data from the California Geospatial Clearinghouse, and I've loaded the site here. And where we want to go is first to download, and I had to do some digging, by the way, to find this, but this data is freely available, and with the Google search I was able to locate this source. It has some excellent data for the state of California. So from here we will go into imagery, base maps, and land cover. And the first thing we're going to download is a DRG, which remember is the topo map. So from there we'll go into base maps and DRG, and then there's a variety of different scales and the trimmed and untrimmed and things like that. We're going to go into the 7.5 minute Albers NAD83 trimmed, and this opens up a set of subdirectories with the USGS naming scheme for the individual quads. And I've provided you with the name in this case for the quad that the two quads we want to get. One of them is Yosemite Falls, one of them is Half Dome, and so we will follow that. We're looking for the 37119 subfolder. So we'll scroll down, and 37119. And this takes us into a set of quads that's occupying the space covered by that larger, it's basically a larger scale quad, either 1 to 100 or 1 to 250,000 scale. And these are the individual 7.5 minute quads that are located in that area defined. So the ones we need specifically, both of them are 37119, but we need G5 and F5. So we'll scroll down, look for the F first. We should see it first here, and here we go. And you'll notice there are two different F5 files. One's an auxiliary file, one is a TIFF file. Go ahead and download both of those. The TIFF, as you look over here, you can see it's the larger of the two. And this also gives us the quad name here, by the way. And the auxiliary file is just another type of file that goes with that TIFF file, and it may be needed in the processing, so we want to make sure to get that as well. So we'll get that one first, and the way I'm going to get this is I'm going to first try right-clicking and then Save Target As. And if this works, it should pop a dialog up here with the name already embedded in it. And this tells me that it is working, and so you want to make sure that the name matches what's on the screen for the download. If we had something like HTML file pop up or something like that, then that would tell me that we need to click on that file, left click, and go into it before we download. So in this case we right clicked and it looks fine. We've got the auxiliary file, and let's go ahead and route it over to the folder structure that we set up earlier. And in this case we'll go into the EXER1 and DRG subfolder, and we'll just locate it there. So we'll save it. Just takes it a minute to download that one because it's pretty small. We do the same thing on the TIFF file. Save Target As, and it's already in the subfolder we need because it remembers we were just there last time. So we can say save and let this download. Takes this one a little bit longer depending on your internet connection speed. It's downloading 12 megabytes, almost 13 megabytes, so it's going to take 10 or 15 seconds even with a high-speed connection. It's not nearly as bad as it used to be. And to save time, go ahead and do the same for the other file. I'll pause this video while you download the other data. One thing I wanted to point out while the second file is downloading, if you notice on the site, the TIFF file on the list here just has one F in it, t.tiff. Yet in the download you can see it's downloading a file with two Fs, tiff. This is a little anomaly that we'll need to correct because the ARC catalog program is only going to recognize the 3-digit extension, not the 4. And so we're going to want to drop one of those F's off by editing the file in the folder name. You don't see this very often. Usually when you download the files they have the 3-digit extension, but in this case they didn't, and if we try to process that we'll run into some problems. So before we do that, let me close this down and pause this just a minute. Okay, if we go into our DRG folder, and I'm going to right click. You can see it's giving me a little profile thumbnail of the data we downloaded, and you can see it is a topo map. But let's view it by details. So you can right click anywhere in the window here, go to view, and view it by details. And yours might be doing that by default. And you can see it does have the two F's at it in the extension here. So let's go ahead and edit that file. We'll click once and then click a second time, being careful not to double click too quickly or else it will try to open the file. So we just click once, pause, and then left click once again. And we're going to select at the end of the file name and just take one of those F's off. We'll say OK, and it gives us a warning because Windows doesn't really like for you to mess around with the extensions, so it gives you a little warning that it might become unusable. We'll go ahead and say yes, we want to change it. And you see it now has the one F in it. Let's do the same thing for the other file. And accept that change. Now we want to go back to the data download site, and I'm going to use my back key to back out. And we want to go over to the folder that's going to have some of the imagery files. So in this case, I'm just going to back all the way out to the beginning. You can see the site from the beginning, and then we'll go back down to download, following the instructions here. And then we want imagery base maps again. And this time we want to go to imagery, and we're going to follow the DOQ/MRSID. That stands for Mr. SID, we call that. That's a type of extension that you'll find that in a lot of cases with aerial files that you download. They end with a .SID extension, and that's just a type of compression routine that's used on the imagery to make the file sizes smaller. It's a proprietary extension by a company that we'll see from time to time on these for when we process these extensions. And in this case, we want to go back into our 37119 subfolder here, just like we did before. Only this time we're in the imagery folder, and at the top of the screen it gives you a little summary of where you're located in the file folder structure. And we want to download the F5 and the G5 again. So we will go scroll down. And there are F5s. And you'll see we've got the .SID file, which is the image file, and it's about 30 megabytes this time. And then we've got an SDW file. That's an important file because it's basically has your projection information in it. So we need to get both of those files. Right-clicked, save target as. This time we don't want to put it in DRG. I'm going to click up one and go back to EXER1, and then we'll go down into our DOQ folder, and that's where we'll save that file, and do the same for the SDW file and then for the other image files. And just be patient while they download. It takes a little longer this time. While we're waiting for the file to download, I wanted to note that while this is a good site for getting data, it doesn't have a very thorough set of metadata with the files. So you have to ascertain some information yourself in terms of the projection being used for these files. A little bit later we'll need to define a projection for these files, or at least some of them, and we don't have the projection information available for us here. So I've gone and checked with some other file information that I have to identify the UTM zone, which I'll give you for this exercise. But just to note, if there were metadata files with these, you'd want to be sure to get those as well. And another thing to note is that we're actually getting a topo and an aerial photo here. And really, for a base map, we only need one or the other. You're not going to be able to see both of them at the same time anyway. I just wanted to give you some practice with getting both sources, and a lot of people like to have an aerial photo, and then other times it's handy to have a topo, so you can always turn one or the other on and the other one off to display it as a backdrop as appropriate. And if you wanted to make a map with just a topo map, say, as a background, then you would be able to do that. And you can always just turn that off and turn your aerial on if you wanted to use aerial imagery. So it's kind of handy to go ahead and get this now. And I'll pause the video here while it's downloading. Once you finish downloading that, go ahead and start up ArcCatalog. I like to run ArcCatalog independent of ArcMap, so I would encourage you to make sure ArcMap is not running when you run ArcCatalog. And then once you're in ArcCatalog, go ahead and route over to the subfolder where you stored your data. So I'm going to follow the C drive into the EXER1. And what we want to do, the very first thing you want to do when you download data, and this is really important, is you want to check and see if your data has been defined, what we call the projection, if the projection has been defined or not. If it's not been defined, you'll need to define it before you try to use it in ArcMap. If you don't do that and it's not defined, then there's a reasonable chance that your data will not line up properly in ArcMap, which can cause you lots of frustration and problems down the road. So that's why the very first thing we always like to do is look at the data in ArcCatalog, make sure everything seems okay and that the projections are defined. If they're not defined, we'll define them here. And so, and remember, as we've talked about elsewhere, that there's a difference between defining a projection and actually reprojecting data. So in this case, we're defining the projection, and note too that it has to be defined in what the data was actually created in. Not what you want it to be necessarily, but what it was actually created in. So in other words, if we wanted this data to be in state plane coordinate system, for example, we could not just go in here and just define it as state plane, because it's already been created in another projection. So we first have to define it in that projection. Then if we really wanted it in state plane, we could then go in and reproject it into a state plane projection. We're not going to do that here, but we are going to actually define it, or at least make sure it's defined. But I wanted to point that out because a lot of people get confused between defining a projection and reprojecting data. And it doesn't help that ArcCatalog and ArcMap, it has their projection utility with a name called project instead of reproject. So it makes it a little more confusing. But just remember, there's a difference between defining a projection and then actually reprojecting data. So let's check to see if the projections have been defined, and let's go first to the DOG data where we had that stored. We'll open that folder. I'm sorry, not DOG, but it was DRG. We'll open that folder. You'll see our two files there, and we can select one of those files, and then let's open up our Arc toolbox. The little icon up here at the top with the red toolbox on it, and it takes it a minute to open the first time. And once that's open, the toolbox, then we will go in and go to Data Management Tools and expand that. And here you see a lot of different tools related to data management. We want to scroll down to the projections and transformations and expand that. And in this case, we simply want to define the projection. So let's double-click Define Projection. And my window opens, and I've got two monitors, and so I have to move one window over here so you can see it on the video. So we've got this dialog here that basically tells us, if you look on the right hand side, if you've got the help option open, it sort of walks you through the dialog. But what we want to do first is we're basically going to load one of our data sets in, and if it's been defined, we'll see a projection down here. If not, it will say unknown. So let's go ahead. In this case, I'm going to drag it and drop it in there since it's easy to find. We're looking at the first layer here. And in this case, it shows us that we do have a coordinate system, a customized coordinate system that has been defined. You don't see that very often. Usually if it's got a coordinate system, you'll see more details about what the coordinate system is. In this case, they've apparently defined it. In some of the projections in California, there's some quirky things that goes on. And so we're not going to question it right now at this point. We're going to go ahead and take what they've defined there for that one. Since it has been custom defined, we'll assume that it is correct for now. And we won't try to redefine that. And that's why we get the little yellow caution box up here letting us know that, hey, there has been a projection defined. So let's go ahead and cancel out of that then. And if we were to view that file, by the way, you can, another way to get a clue that it has a projection defined, and this is not the best way per se, but I'm going to say no on the pyramids, is to look at what the coordinate system is down in the lower right. Once that loads, you can see down here in the lower right that we're definitely not dealing with a geographic type coordinate system, or else we would see a range of numbers that was different than this. This is definitely some type of UTM or state plane. In this case, it's UTM, but it's not geographic. So we'll go ahead and assume that they've got everything defined properly for that layer. And if that one's defined, then there's a good chance that the other one is, because it's the same type of data source. So I'm just going to spot check it by looking at it in the preview window here. And again, I can see a similar type coordinates at the bottom of my screen that do not appear to be latitude and longitude. So we will go ahead and check our other data source then, which was the DOQ files. And let's switch back over to the content window so we're not taking up memory there. We'll click on Define Projection, drag and drop one of those in there. In this case, it says unknown. So we know here that the projection has not been defined, and so we do need to define it. We don't have any warning symbols here telling us that we can't do that. And so what do we define it in? Well, it needs to be defined in what the data was actually, what the data was actually set up in to begin with. And they don't have a lot of metadata, as I pointed out before back on the site, but I was able to do a little bit of digging and found out that it was UTM, and so then I used my UTM map that I had to find out that that area of California is in Zone 11. So what we want to define in here is UTM Zone 11, and the datum was 1983. So we'll define that by clicking the little dialog here. We're going to select a projection. We want the projected coordinate system, so we double click that. And then we go to UTM and NAD 1983, and we want Zone 11 North. So we'll click that and add it. Say apply and OK. And you see the coordinate system now in the dialog here, but it's not been defined yet until we execute it. So let's go ahead and say OK. And the first time you run this projection utility, you're going to have to wait a few minutes for it to run. It's working in the background right now. Once it finishes, you'll see a little dialog pop up in the lower right corner. On my computer, it's probably going to pop up on the other window, so you might not actually see it here on the video. But on your end, you should see when it's complete, it should pop up a little dialog box in the lower right. You can see that it's working. If you look at the bottom of the screen down here, you can see that it is the little blue scrolling text here. It tells you that it's defining. So it's right now it's processing it, and we'll see when it finishes what the dialog does. Takes it just a minute here, and once this tool runs the first time, if you have to then turn around and define another file while you're in the same session of ArcCatalog, then it will work a lot faster. Yeah, the dialog did pop up in the lower right of my other window, so you don't see it here, but it did pop up. So that one has finished executing, so I can go ahead and define the other file now. I'm just going to drag and drop it in there too. And unknown, so we'll do the same thing for that. Select projected UTM NAD 1983 and Zone 11. Add, apply, OK, and OK. And this time it should work a lot faster. You can see it's already processing and it's already finished. So we now have projections defined for both of the raster types of data that we've downloaded, and we can go ahead and load those into ArcMap if we want to. In this case, before we jump into ArcMap, let's go ahead and get some more of the data that we need. The next type of data we're going to get is a vector data source with the DLG data that we've already talked about before, and we're going to get that from the GIS Data Depot site. And because we'll probably have to process that as well in terms of defining a projection, or at least checking to see if one has been defined, I'm going to leave my Arc catalog window open. I'm just going to minimize it and jump into my Windows Explorer browser. And I'll have a link to the Data Depot site in our weekly materials. And remember, this is a site that if you haven't set up an account, you'll want to set up an account with them. They do require you have an account before you can download data. It is a private commercial site, but most of the data that they have is actually from public sector sources such as the USGS and Census Bureau. So we will, in my case, I'm going to go ahead and log in. And if I've identified it right off the map, we're looking for Mariposa County. So we'll click that. And then here we have choices of a lot of different data types. We're interested in the DLG data, the 1 to 24,000 scale. We will select that. And then these are our topo quad names with the identifier numbers. And again, we were looking for the Yosemite Falls and Half Dome quads. So let's scroll down and see if we can find that. And we see there's the Half Dome. So let's go ahead and select that one. And you can see we have a variety of different DLG data types. And in this case, just for the example, we're just going to use the hydrography and the hypsography, which would basically be our streams and contour lines. So we'll select the hydrography. I left clicked on that one time, and a little dialog at the bottom of my screen tells me that it's asking me where I want to save it. So we're going to go ahead and route this back to our working project folder again, except instead of DOQ we want to go into DLG, and we'll save it there. And then do the same thing for the hypsography. Save as, and save. That's pretty quick. And then we'll use the back key here to take us back to the previous page, which is kind of handy because you don't have to start from the beginning then to drill back down into the county of interest. And then we want to go down to Yosemite Falls, which is the last one on the list. Download that. Same thing here as before. We want the hydrography and the hypsography. We'll select that. And notice I'm saving these in the same subfolder. If you had a bigger project where you were downloading a lot of data, you might want to have subfolders for each quad or some other way of keeping things separate. But in this case, we only have 2 quads, and I'm just going to put them in the same subfolder. And notice the way they're coded, I could not tell which was which by looking at just the names at this point. And that would be another reason you might want to create a subfolder so you can identify which quad you're working with. But again, in this case, since we only have 2, and for the sake of a simple example, we're just going to put them in the same subfolder, just like we did with the raster data earlier. Now that we have that downloaded, we need to process that data. And there's a separate video that will be available soon, if it's not already available by the time you see this, that discusses a little more detail, and it goes through an example of processing data, DLG data, with a utility tool that you're going to need to install. And again, we'll have more information about this separately on terms of the program and where you can get it and things like that. But the utility that we're going to use, it's one of the GIS tools utilities, and the name of it is called DLG2Shape, like DLG the number 2 SHP. And basically what it does is it converts USGS formatted DLG file into a shapefile for you. Very handy utility. It was created by Dr. Bruce Ralston and some of his associates that we've talked about earlier in terms of the book and some of the slide programs and stuff that we're using. So it's a handy utility to have, and that's what we'll use to process this with. So I'm going to go ahead and start up that program now, and it opens in my other window, so I've moved it over here. Let me minimize some of these dialogues here so we can clean up our window a little bit. And there you can see it's basically a very simple interface that goes with this program. And in case we don't have the other demonstration video available by the time you're working with this one, I'm going to walk you through it step by step on how to run this program. Pretty easy. It basically walks you through it again. It's asking us for the DLG files to process. So what we want to do is add those files that we're interested in processing. So I'm going to click the Add button and give it just a minute. It will pop up a folder structure, which of course comes over on my other window. So let me move it over. Okay, and it's remembering the last time I used this program where I was located. So let me route it over to the C drive, and we need to go into our working folder, go into the DLG subfolder, and we have 4 different files here. One representing streams, and then contour lines for each of the 2 quads that we downloaded. So what we can do in this case, and this is one of the handy things about this program, these files are compressed that we downloaded. And normally with a lot of utilities you have to uncompress those files before you can process them. But with this utility you can leave them compressed and it processes them internally. So it saves space, saves time, and keeps you from having to process a lot of data. Each one of these compressed files contains a number of files, maybe 12 or 13 individual files for each of these zip files. So it can be a lot of files, a lot of information out there. And luckily with this particular utility we don't have to unzip those to process them. So I'm just going to go ahead and select the first one and then hold my shift key down and select the last one, which effectively highlights all of them. Then click on open, and then it wants me to specify the output directory where I want the results to be stored. By default it's putting them in the subdirectory where our zip files were contained, and that's where I'm going to leave it because I want my DLG data to ultimately stay at least within a subfolder within the DLG folder. So we'll say OK there. And actually I can click on use this for all subsequent cases so it doesn't ask me for each of the 4 files. And then it downloads the file, or it loads the files into the dialog for me there. Tells me what it's processing basically. So we have added the files, and we don't need to edit the output directory because we selected the one we wanted in the dialog. So we're good there. So we should be good to go. So let's just click on the go button and let it process. As it processes, you can see information in here about the reference system, the zone, it's UTM zone 11, basic information that it's using out of those zip files. The program is pulling this information out of the zip files to process. And it doesn't take it but a minute and it's finished. So let's open our Windows Explorer up and see what it did. Go to the DLG subfolder, and here you can see what happened is it created, in this case, 5 different subfolders. One of them is just called unzipped, and unzipped is actually, if you look in it, it'll be empty. Unzipped was basically a temporary file that the program creates for like a working file to do its processing in, and it doesn't, for some reason it doesn't delete that automatically. So we're going to go ahead and delete that since it's empty and we don't need it in there any longer.